Okay, so in this video we're going to look at various problems revolving around speed, distance and time. So this is the formula we're going to use here. Speed is equal to distance divided by time, and we usually measure speed in kilometers per hour or meters per second or even miles per hour if you're talking about the imperial system, but we're going to use kilometers per hour, meters per second. So kilometers and meters, they're distances, so they're on the top. Hours, seconds, they're on their time, and they're on the bottom. Now you can use this triangle here, D for distance, S for speed, T for time. So speed is distance divided by time, time is distance divided by speed, or distance is speed multiplied by time. Now if we take an object that's traveled, for example, a distance of 100 kilometers, and it is traveling at a speed of 50 kilometers per hour, what time will it do it in? So we can see time is distance divided by speed, so time is equal to distance divided by speed. Distance is 100, speed is 50, that gives us 2 hours. So if an object has to travel 100 kilometers at 50 kilometers per hour, it will take 2 hours. Okay, so that's a very basic example. Let's have a look at another one. Let's have a look at something that travels at a speed of, let's say, 375 kilometers per hour. And let's say it takes 3 hours and 12 minutes. We want to know then what will the distance be. So what will the distance be? How long, or yeah, what the distance is. Okay, so now I'm introducing this one because I want to have a look particularly at converting this 12 minutes into hours. So that's going to be our problem here, because remember, this is kilometers per hour, not kilometers per hours and minutes. So it's kilometers per hour. So everything has to be in hours here. So we have hours and minutes here, so I've got to convert this to just simply hours. Well, we know it's going to be 3 hours, and it's also going to be 12 minutes. Now, what fraction of an hour is 12 minutes? Well, it's 12/60ths of an hour. So this is it really. So that's 3.2 hours. So you need to put this 12 over 6. You need to divide the 12 by the 60, because there are 60 minutes in an hour. Don't get this confused. Don't write down 3.12 hours. It's not 3.12, it's 3.2. Remember, we're not dealing with tens and hundreds now. We're dealing with 60s. There are 60 seconds in a minute, 60 minutes in an hour, and so on. So this 12 is 12/60ths of an hour, which is 0.2. So this particular object has traveled for 3.2 hours. So now we can work out the distance. So if we look at our triangle thing here, where we have our speed, distance and time, we have distance, which we want to work out. So we want to work out distance. So our distance here is going to be, our distance is speed multiplied by time. Speed multiplied by time. So in our case, our speed is 375, our time is 3.2. That gives us 118.4 kilometers. 118.4 kilometers. So that's the distance that this thing has traveled. Okay, so let's have a look at another example then. So let's have a look at an object that does, or say a person. We'll take a person, and the person has traveled by by car and then by train. So what's going to happen is the person is going to drive to a train station, for example, and then get on a train and travel another distance. So let's just draw that out. It's usually a good idea when you get long questions, kind of essay type questions, it's a good idea to draw a little diagram of what's actually happening. So it kind of summarizes everything. So let's take, we'll take this as part A of the journey. She's going to move on to part B. This is the car part of the journey, if you like. So we'll just write car up here. And then she's going to get on a train and she's going to go another distance here, let's say C, and this is the train journey. Let's stick in the different bits of information. So it's going to take 1 hour and 6 minutes. So it's going to be 1 hour and 6 minutes, 1 hour 6 minutes by car, and that's going to be 55 kilometers. 55 kilometers. Okay. Now then she gets on a train and she heads off, and the train travels a distance of 110 kilometers, and at a speed of 80 kilometers per hour. Okay, so this is our entire question summarized here. So let's just do the bits and pieces that we might be asked to do. Let's see. You can see here, you know, when you have speed is equal to distance over time, there are three unknowns here, or three variables here, if you like, s, d, and t. If you have two of them, you can work out the third one. And you can see here in both parts of the journey, we have two things here. We have time and distance, so we can work out speed if we need to. Here we have distance and speed, so we can work out time. So let's just do that. Let's work out the speed here first of all. So we can see that speed is distance over time, so that's straightforward enough. Now our distance is 55 kilometers, but our time here rather is 1 hour 6 minutes. So if we take 1 hour 6 minutes, 1 hour and 6 minutes, we need to convert that to hours. So that's going to be 1 hour, and it's going to be 6 over 60ths of an hour, 6/60ths of an hour. So that's just simply 1 1/10, or 1.1, we'll say 1.1 hours. So 1 hour 6 minutes is 1.1 hours. So that's fine. We have now our time as a decimal, and we have our distance. So let's just stick those in. Our distance is 55, and our time here is 1.1. That gives us a speed. That gives us a speed of 50 kilometers per hour. 50 kilometers per hour. So we could write that up in here if we want. 50 kilometers per hour. We now have all three data points here, if you like. So let's have a look here. We have what do we have here? We have distance and we have speed. So we can find the time here. So let's do that here. So we want to find time. Now time is going to be, looking at our triangle again, time is just simply going to be distance over speed. So we have our distance here, it's 110 kilometers, and we have our speed as 80 kilometers per hour, so everything is okay there. We don't have to do anything unusual there, and that comes out at 1.375 hours. So we could put that up here, 1.375 hours. Okay, so what you may be asked in these type of questions as well is, what is the overall average speed? Now the overall average speed is the overall average distance divided by the overall, it's the overall distance divided by the overall time. So you just take we'll actually do that, we'll do that down here. So let's see. We want to do, this is the third part of the question, so we want the overall average speed. So that's going to be distance over time again. Now the overall average speed, you just simply take the overall distance, which in our case is 110 kilometers plus 55, so that's going to be 165 kilometers. So that's our overall distance. Our overall time then is going to be 1.375 hours plus, this is actually 1.1. We work that out as 1.1 hours. So that's going to give us 2.375 hours. 2.475 in fact, I think, isn't it? Let's see, it's 1.375 plus 1.1, so it's actually going to be 1.475. So that's going to be 1.475. Okay, so when you do that, then you just simply get, let's see, 165 divided by 2.475 is actually 66 and 2/3 kilometers per hour. So that's the average speed, remember. She goes at two different speeds here. She goes at 50 kilometers per hour, and then the train goes at 80 kilometers per hour. But the average speed is the overall distance divided by the overall time, which is 66 and 2/3 kilometers per hour. Try not to write this 2/3 as 66.6, unless you're specifically asked to write it to one decimal place or two decimal places or three decimal places. But the 2/3 is the exact fraction here, if you like. It's not 0.6 or 0.7 or 0.666. they're only approximations really. So unless you're asked to write it as a decimal, or as a decimal to 2 or 3 or 4 decimal places, leave it as 2/3. Okay, so that's that part of our video. So let's have a look at just something else I have down here somewhere. See if I can pick this out. Oh yeah, there we go. Okay, so we have here a graph, and this is just simply a graph of a distance. It's called a distance time graph, okay? A distance time graph. And what we're going to do, this is a journey from 8 o'clock to 8:50. The time is along here on the x-axis. So the person starts at 8 o'clock and finishes or stops at 8:50, or gets to the destination at 8:50 or 10 to 9. Now this is distance up along here in kilometers, so they start at 0 and they finally arrive at their destination 2.5 kilometers later. Okay, so the various things that you need to note here from this kind of a distance time graph would be, you need to you may be asked, what time did the person start at? Well, the start time is just simply 8 o'clock. 8 o'clock. What time did they get to the destination? Well, then it's so the destination, if you like, destination time is just simply 8:50, 10 to 9. So how long did it take then? How long did it take? It took 50 minutes. 50 minutes. Or if you want to put it in hours, that's 50 over 60, or 5/6 of an hour. 5/6 of an hour. Okay, so that's how long it actually took. You could also be asked, how far was the destination from the start point? So you need to look at E here, get a ruler and bring it across here, and you'll find that it's actually, they start at 0, so it's 2.5 kilometers. 2.5 kilometers. So it's 2.5 kilometers to the destination. You also may be asked something like, how far was it from point B to point C? So what you would need to do is get a ruler, go across to here, starting really at B here at 0.5, and you're finishing at C here, which is 1. So this distance here is 0.5 or half a kilometer between B and C. And if you were asked for the speed, you would just take the time here, and then you would take the distance divided by whatever this time is between 8:10 and 8:30. That's 20 minutes. Convert that to hours and work out speed as distance over time. So that kind of thing you can be asked. You can be asked, for example, when did the person stop? Between what 2 points did the person stop, maybe for a chat? So that would be between C and D. Between C and D they stopped, okay? They stopped there. You can be asked, when did the person travel at the fastest pace? So you can see here they started from A to B at a steady pace. They slowed down here, and then they stopped for a chat or whatever here, and then here they set off again very fast, or faster anyway than these two sections here. So to work out any individual speed, I'll just work out a particular speed. Let's say we'll take between B and C actually, and we'll just work out what the speed is. So let's see what way we could do that. Let's see, we'll take this as part 6. So speed we know is distance over time. Distance over time, okay? So what distance did they travel between B and C? We worked out B is 0.5, C is 1, so that's a distance of 0.5. 0.5. So what's the time? The time is 8:10 to 8:30. That's 20 minutes. That's 20 minutes. 20 minutes is 20/60ths of an hour. Remember, you have to convert to hours. So that's 1/3, or 2/6 or 1/3. Now 1/3, I'm not going to convert that to decimals. I'm just going to leave it as 1/3. So I'm going to divide by 1/3. Divide by 1/3 there. Okay, so it's 0.5. So it's 0.5, and you have to divide that by 1/3, and that gives you a speed. Speed here is going to be 1.5 kilometers per hour. And that's it really. Let's see, what other kind of questions can you be asked? You can be asked the overall average speed. The overall average speed. So you would take, let's see, if we did that, what would we get? What are we on now? 7. So the overall average speed again is distance over time. distance over time. So the overall distance rather is 2.5 kilometers. It took 50 minutes. Now remember 50 minutes, if we were to look at that, 50 minutes is 50 over 60, which is 5/6 of an hour. So we're going to divide here by 5/6. So let me just get my calculator and we'll do that one quickly. So it's 2.5 and we want to divide that by 5/6. So that gives us 3. Just 3 kilometers per hour. Now you have to remember that's the overall average speed. They travel at this speed, they travel at this particular speed, then they slow down, then they stop, then they travel very fast here. So this 3 kilometers per hour is an overall average speed. Okay, let's move on then to the same type of graph, but I just want to, actually we'll come up here, I think this time there's a bit of space up here left, so I just want to draw a few graphs here before I move on to my last graph. So if you take your distance time, we'll do 3 of them, distance time graphs. So this is distance, this is time, distance time, distance time. If you take a graph that looks like this, it's just a horizontal graph like that. That means that distance is not changing. The distance is remaining the same. It's not going up or down. The time always moves forward. The time is not going to go backwards. You can't go back in time. So we're always moving in this direction, but either up or down like this, okay? So in a straight line, the distance hasn't changed, so the person has stopped. If you take something like this, say the person starts here and they move like this, so in a kind of a curve like this, that means that the person is moving off, the time is moving on, the distance is increasing, but it's increasing faster and faster and faster. So the person here is speeding up. If you take someone who starts here and they move down like this is a person that's slowing down, or a car or a train or whatever that's slowing down. You can see the distance is getting less and less and less. The time is moving on, so this person is actually slowing down. Now there's another type of graph that I just want to briefly look at, and it's called a speed time. So this here is called speed on the y-axis, this is speed, and this is time here. And we look at 3 different graphs again. So again, this is speed, and this is time, and again speed. This is speed and time here. Okay, so if we take a straight line again here, let's take a horizontal line. Now remember here with the distance time graph, if the line is horizontal, the distance is not changing. If distance is not changing, the person has stopped. However, it's different here with a speed time graph. The line is horizontal, which means his speed is not changing. If his speed is not changing, that means he's moving at a certain speed. That means his distance is changing. So he is actually moving here, but he's moving at a constant speed. Now, if you take someone who starts here and is moving like this means over time the speed is getting bigger and bigger. His speed is increasing. If speed is increasing, the person is accelerating. He's pushing his foot, if he's in a car, pushing his foot on the accelerator, he's getting faster and faster and faster. The speed is increasing. And similarly here, if the line is like this, straight down, this is supposed to be a straight line, speed is getting smaller and smaller and smaller constantly, so the person is decelerating. So this is accelerating, this is decelerating here. Okay, so these are our distance time and speed time graphs. Just one last thing I want to have a look at, and that is this graph down at the very end here. This is a graph of 3 people who start a race. So you've got Adam, Barry and Carr. They start a race. This is the time on the bottom here. On the x-axis you've got time. On the y-axis you've got distance from the race start. So this is distance from a particular point. So this is your race start here, if you like. The 2 people here have started. This person here has got a head start. This person is a little bit slower and has got a head start. So this person here, these 2 people here have headed off together, and this person here, this is Carl, he's got a 1 kilometer from the start head start. Okay, so the three of them head off. Which one do you think will actually win? Well, this is time along here, So which person has finished the race, has done the 10 kilometers, remember it's a 10-kilometer race along here, so they all finished their 10 kilometers, but Adam here has done it in the fastest time. So we would say that Adam has won, okay? Followed by, then you've got Barry, and despite the 1 kilometer head start, Carl has come in last, okay? So you might be asked things like, when did Adam pass Carl by? So here you've got Carl running along here, and you've got Adam running along here, and Adam overtakes Carl at this point here. So it's roughly, I don't know, about 7.5, 8 minutes. After about 7.5 or 8 minutes, Adam has passed Carl. Now, what about Barry? Well, Barry has passed Carl at this point here, and that's roughly just under 20 minutes, maybe 19 minutes or so. Now, what has any of them stopped at any point? So you can see here that we have a horizontal line here, so you can see that Barry, he stopped maybe to tie his shoelace, or maybe got cramp, or stopped for a drink or whatever, but he stopped here, and he stopped for roughly 40 to 45, roughly 45 minutes he stopped. Let's see, what else? You can see here that Carl has run along at a nice steady pace, and then after 50 minutes he decided to speed up, and this line here indicates that he's actually running a lot faster here than he is here. The slope of this line is bigger than the slope of this line here. And that's really about it. They all finished the race after 10 kilometers. Adam won, Barry came second, Carl was third, and that's about it. That's about it for speed, distance, and time for the moment.